We're graphing parabolas from vertex form, and this is the most complicated one that we're going to see. So if this one is really hard for you, go back and see some of the other videos where we graphed them without an a value in the front. And what I mean by a value is, remember, our vertex form is y equals a times x minus h squared plus k. So this a value here does a vertical stretch or compression, and so it's easier to see before you have the a value and then we have to add that in. So if you're still confused, go ahead and look at those first and then come back to this one. All right, so just remember that this is just a transformation of the original parent function y equals x squared. So we can just graph it as a transformation. So we can start with the parent function. And remember, the pattern of x squared is over 1, up 1, over 2, up 4, because that's the pattern of squaring, right? We square 1, we get out 1. We square 2, we get out 4. So that's our pattern. So here we have x, this is just y equals x squared. Now we need to transform it. So if you remember, we're going to do the multiplication and division first, and then we're going to shift it. So this a value right here is 1/4. And now, is it inside the function or is it outside the function? This one's outside the function, right? So because it's outside the function, it affects y values and not x values, okay? So all it's going to change is our y values. And because it's a y transformation, y doesn't lie, so it does exactly what it looks like. So right here, it looks like I'm multiplying my function by 1/4. So that's exactly what I'm going to do. I'm going to take my y values, my output, and I'm going to multiply them by 1/4. Okay? So my input, or my x values, don't actually change, only my output, or my y values, change. So if I input 1, it outputs 1. But if I multiply all my output values by 1/4, it's going to make that 1/4, right? And that's really hard to graph. So let's go to the next one. If I put in 2, I normally get out 4. But it's going to take my y value and it's going to multiply it by 1/4. So 4 times 1/4 is actually just 1, right? So this is going to be here. And then we had like at 1/4 and then at 1. Okay, and then let's look at some more. So what would normally happen if I input 3? Normally I would get out 9, right? Because 3 squared is 9. So now I'm going to get 9 times 1/4, which is 9/4. And that's kind of complicated to graph, so let's go to the next one and see if it's easier to graph. If I input 4, I'd get out 16, because 4 squared is 16. But now I'm going to take all my y values and divide them by 4, or multiply by 1/4. So if I take 16 and I multiply it by 1/4, I get out 4. So I go 1, 2, 3, 4, 1, 2, 3, 4. So when I input 4, I'm actually going to get out 4 as well. So this blue function is what it looks like after I take my y values and multiply them by 1/4. Because if you think about the original function, and I know this is going to be a little bit overkill for some people, but I think it's important to see this. This 1/4, it actually changes the pattern, right? The 4 and the 5, all they do is shift it one way or the other. But the 1/4 actually stretches or compresses it, so it changes the actual pattern of the function. So this is my normal pattern. When I put in 0, I get out 1, a 0. When I put in 1, I get out 1. When I put in 2, I get out 4. But what this 1/4 does is it changes this output, right? It multiplies all of my y values by 1/4. So my new pattern is when I put in 1, I get out 1/4. When I put in 4, I get out 1. When I put in 9, I get out 9/4. And when I put in 4, I get out 4. So it just changes my pattern. So that's what that a value did. So we took care of that. Now we can shift it. Now that we've done all the multiplying and dividing, we can go ahead and shift it. So we're going to take this, and remember your x is a liar. So this looks like I should shift it left 4 because it says negative, but I'm not going to shift it left 4. I'm going to shift it right 4. So I take it right 4, 1, 2, 3, 4, and I just start. The vertex is the easiest one to shift. And then I move it up 5. 1, 2, 3, 4, 5. Okay? So I go there, and then I've changed my pattern from here, right? So what I'm doing is I'm taking this blue one and I'm just copying and pasting it over 4 and up 5. But if it's hard for you to see what these ones would be from there, let's just go with the pattern. We already changed our pattern, right? So from the vertex, I'm going to go over 1, up 1/4. That's too hard to graph, so I'm not going to graph it. From the vertex, I'm going to go over 2, up 1. Okay, so my new point is going to be right here. Over 2, up 1. That's the new pattern, okay? And then the next pattern says from my vertex I go over 3 and up 9/4. That's pretty hard to graph, so I'm going to go to the next one. From my vertex I go over 4, 1, 2, 3, 4, and then I go up 4, 1, 2, 3, 4. And then I go the other way, 1, 2, 3, 4, up 4, 1, 2, 3, 4. So my final parabola is going to be the green one. We can just get rid of all of those. That is this transformed parabola with all of the transformations, with the vertical stretch or compression, which in this case it's a compression, with the horizontal shift and the vertical shift. So now let's see if we can figure out some of these features of our function based on that. So what's the axis of symmetry? Remember, the axis of symmetry is just straight down the middle. So it's right on our vertex. So actually, let's write our vertex first so we can find our axis of symmetry. Well, our vertex is at 4, 5, because remember, x is a liar. So if I see -4, it's actually at 4, and then the y-coordinate is 5. So that means my axis of symmetry is at x equals 4, because that's the x-coordinate of the vertex. The direction of opening is up, because my a value is positive. If the a value is negative, the direction of opening would be down. All right, what's my max or min value? Remember, the max or min value is just the y-coordinate of your vertex, so this is going to be 5. What are my zeros? Well, I don't have any because it went above the x-axis, didn't it? And then what's my y-intercept? In this case, I happen to have it on the graph, so I can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is at 0, 9. Remember, the other way to find your y-intercept is you can just set 0 in for x, because at the y-axis, x is always equal to 0. It's 0 minus 4 squared plus 5. So I have 1/4 and then -4 squared plus 5. Now remember, I always do exponents before multiplication, so I square that -4, so I get 1/4 times 16 plus 5, and then 1/4 times 16 is just 16 divided by 4, so that's 4, and so that's 4 plus 5, so y equals 9. So when x equals 0, y equals 9. I just put 0 in my toaster, and it spit out 9. So that's my y-intercept, and there is your final transformed function in vertex form.